Okay, friends. So, few more important applications for the induction. See, any uniform magnetic field. Let's say that magnitude of the magnetic field equal to B Tesla. Earlier, we have seen only translatory motion of the rod. I mean, linear motion of the rod only we have seen. This time, a same pure conducting rod, instead of linear motion, it is in the rotatory motion. Like this. So I am taking one rod, pivoted at one particular point O. Let's say the length of this rod equal to some L meter. It is pivoted at point O means about this point O, it is rotating with some constant angular speed. Let's say its angular speed equal to some omega. It is rotating with a constant angular speed. How much? Omega radians per second. So definitely, as it is rotating, because of its motion, definitely less or more there is some electromagnetic induction taking place. If you have doubt, take one small element. I'm taking this small element at a distance x meter. At a distance x meter means what is the length of the element equal to dx meter. When the rod is at this orientation, if you drop any perpendicular line to the rod, that is representing linear velocity of the rod. Yes or no? See here, length is, the velocity of the element is perpendicular to length, and length is perpendicular to magnetic field. Just watch the element alone. What do you notice the element? Length of the element, length of the element is perpendicular to magnetic field, and magnetic field is perpendicular to its velocity. My question is, what is the EMF induced across the element? Who will tell the formula? I can use directly. B is the EMF induced across the element. That is how much? B into L into V. What is the length of the element equal to? Dx is the length of the element. And what is the linear velocity or tangential velocity of the element? It is revolving in the circular orbit. Something is rotating with the angular speed omega. What is the linear velocity? R into omega. But here, what is the radius of the circular orbit? X. So I can write omega into x. What about the polarity? You have to use the same right hand palm face rule. Same, take your right hand. This stretched fingers keep along the magnetic field. Keep your thumb in the direction of the velocity of that element. Then palm face is representing high potential and this is the low potential. That element is also acting like a tiny cell without internal resistance. But like that, how many cells are there? All cells are in the series combination. Every element is acting like a cell. All cells are in the series combination. So what a net EMF? E1 plus E2 plus and so on. Means compulsorily you have to do the integration. Yes or no? In the series combination, addition operation you have to perform. Addition is nothing but what here? Integration. What integration of 1 into dE? EMF E and B I will take outside. Omega also will take outside. Why? Because I only told those are constants. And instead of, so we are not doing integration for B omega. Only X is changing, dx is changing. Understood? So integration of X into dx. Where is first element is residing? First element is at X equal to 0. And where is the last element? X equal to L meter. So add all that EMFs of all elements from first element is at x equal to 0 and last element is at x equal to L meter. So what is the EMF induced across the rod? B into omega into what integration of x power 1? X square by 2. So put the limits L square by 2. This is the EMF induced across the rod. If you connect any external resistance, you can also calculate induced current also. Or suppose I connected one electric bulb. I connected one electric bulb of, let's say, resistance how many ohms? R ohms. What is the induced current? How much? EMF by resistance. You can substitute the EMF value. What is the power induced? I square into R. What is the electric field that is induced? What electric field induced formula? EMF induced divided by shortest distance between the high potential term and low potential term. Just now we found EMF induced, that is how much? E omega L by 2 is the electric field that has been induced, directly at it. I substituted EMF induced, divided by length is there now. L will be cancelled out. So E omega L by 2. Understood? So one small task for you. Understood? Instead of single rod, I am adding multiple rods. So I am making a wheel. Wheel, you know, bicycle wheel, etc. Just like a spoke. Each rod is acting like a spoke. So it is multiple spokes are constituting some wheel. Okay. Same as usually. I'm not changing any magnetic field here. Same magnetic field I am keeping. How much magnitude? B Tesla. Now this time I am taking one wheel here. What I am taking? Wheel. So here one rod is there. 1, 2, 3, and 4. Length of the each rod or each spike equal to how much? L meter. It is also rotating with some angular speed, omega. My question is very simple and very straight. One point O is there, one point A is there. What is the EMF induced between O and A? Your time starts now. Try and tell. As I told, every rod is acting like a cell only, na? Yes or no? So you can remove this each and every rod. In the place of the rod, I can replace the cell without internal resistance like this, na? With your permission, correct or wrong? This also cell. 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 Everything. 1000 spokes are there. 1000 cells will be there. Are you understanding? Okay. Now all these cells are in which combination? Parallel. Why? If you assume here potential is X and if you assume here potential is Y, potential drop across every cell is X minus Y and X minus Y and X minus Y. What a net EMF of all these cells in the parallel combination? How much? E only, ma. If you substitute also E by R1 plus E by R plus and so on, 1 by R, 1 by R, 1 by R, you can take outside, cancels. So what a net EMF for all identical cells connected in the parallel combination? How much? Here also how much? Net EMF equal to EMF of each cell or each rod. That is how much? Half E omega into L square. I will make more denser. Instead of few spokes, I will add infinity number of spokes. So what will happen? instead of few spokes, completely with the infinity number of spokes, well, what will happen? Disk will come. Instead of wheel one, disk will come. So in the disk case also, same magnetic field with the highly densely packed spokes, it will constitute one disk. With the disk of radius how many meters? Let's say r meters. Let's say r meter. It is rotating with some angular velocity omega in the magnetic field. Here also between the center and any terminal point, what is the EMF induced here? What is the EMF induced between midpoint of the disk and any terminal point I am asking? How much? Same thing. Half into d omega into how much? R square. I mean, to glow the bulb or to function any kind of device, you have to connect those terminals between center point and end only. For your understanding, I will take this 0 volt and I will take this is 2 volt. Then every terminal is having 2 volt only. Na? If you connect any bulb between any two end terminals, will it be glowing? No. Why? Potential drop how much? 2 minus 2 is 0. So there is no potential drop, means you put any external resistance between two terminals, so no induced current is there, no current will flow, no electric field is induced, no power also will be dissipated. I hope everyone understood very well, right? Now here, the concept of self-induction. By seeing the term only, you can understand what is the meaning of the self-induction. Earlier, to produce some current in the coil, you have to use the one coil I have given to your hand. I want to produce some current. For that, what you have to do? External magnets you have to bring. External magnetic field you have to bring, and that external magnetic field should keep on changing. Yes or no? That is called only induction. If you rely to induce the current on the external magnetic field, that is called only induction. But in here, what's this title? Self-induction. I mean, due to its self-change in magnetic field. Understood? Due to its own change in magnetic field, already original current is there in the coil. You take one coil, already some original current is there. It will produce some original magnetic field. When its original magnetic field is changing, for one example, I will explain. For example, I am taking one long solenoid. What is this? I am taking one long solenoid of turn density, let's say small n. Here I am not keeping the current constant. The current keep on changing. As the current keep on changing, what will happen? Tell me. The magnetic flux, the magnetic field linked with the coil also will be keep on changing. Only single system is there. We are not relying on any other second system or external agent. Original current is how much? I am here. It is producing magnetic field. What is magnetic field produced by the current? V is equal to how much? U naught into N into I. So to change its own magnetic field, what I have to do? The current in the solenoid keep on increasing. You know the magnetic flux associated with the solenoid. According to right hand thumb rule, curl your fingers in the direction of the current. So all the magnetic field lines are going out like this. As you are growing this current, subsequently the number of magnetic field lines also will be increasing. So magnetic field also will increasing. So magnetic flux also will increase. So here I can write one statement. So here I can write one statement. The total flux, number of magnetic field lines linked with the coil. For your reference, I have taken long solenoid, but there is no rule that I have to take only solenoid. I can take square coil, I can take circular coil, I can take triangular shaped coil. That is of my choice. So shall I write one statement? The magnetic flux, shall I write directly proportional to original current in the current? Please say yes or no. As you are increasing the current is doubled, subsequently magnetic flux also will be doubled. To give a perfect equation format, I can keep one is equal to symbol. I have to keep one constant, that is called what? Coefficient of self-inductance. Understood? So that is equal to I. So here how I can define the coefficient of self-inductance? The coil which is having more conductance, even though small amount of current is flowing, if it is accommodated more number of lines, more flux, you can say that coil is having more coefficient of or more self-induction. Or understand, for example, many in our day-to-day life, many devices are there. Self-induction coil, self-induction motor, example in the fan and in the motor, which is drawing the water from the well, etc. Everywhere motor is there. The AC generator also. Many devices, this concept will applicable. So I can write here, if for example, one magnetic field line is flowing when 1 ampere current is flowing, then you can say that coefficient of self-inductance equal to how much? 1 Henry. So the inductance is measured in the Henry. Let me explain some examples for the self-induction for various devices. Why here already we have taken long solenoid, so we will take that only first. I'm taking one long solenoid. Long solenoid means the number of turns are undefined and the length of the entire solenoid also undefined. When your observation started, for suppose, let's say I amperes of current is flowing. Let's say turn density is small n. And now we have to find the coefficient of self-inductance. I forgot to give one parameter. Let's say the area of this circular cross section equal to, for suppose, capital A. Now how I can calculate the coefficient of inductance? Tell me. Coefficient of self-inductance of this long solenoid, how much? Net flux flowing in the entire solenoid divided by current flowing in the coil. What is net flux is nothing but, how much net flux is nothing but respond. Number of turns in long solenoid and into flux in each coil. Correct or not? If one line is passing through coil, you should not tell total flux is 1. It is incorrect. Why? Respond. One coil is cutting one line means if 10 turns are there, how many lines you have to tell? 10 turns, 10 lines are there you have to. If one line is passing, if someone questioned you, what is total flux passing through coil? How much? 10 into 1. 10 lines are passed. That's what I have written n into pi, not pi. Pi means flux passing through single turn only. So I can write, tell me what is the flux passing through single turn? How much? E into area of the each turn and into divided by I. What is the magnetic field at any point inside the solenoid, long solenoid? U naught into small n into I and into A divided by I. I cancels out. But as I told you, capital N is undefined. That capital N is undefined. Why? Number of turns are undefined, length also undefined. Can you continue this capital N? So it is incorrect now. So small n, what I can write here? N by length of the solenoid, let's say. So capital N value, what I can write here? U naught into small n into L and into N and into A. So what is the coefficient of self-inductance for the long solenoid? How much? U naught into N square A into L here. Hereafter, you have to keep this expression compulsory in your memory. The coefficient of inductance for the long solenoid. Now one small task I will give based on this concept. Take your own time and try. Now instead of long solenoid, shall I call long solenoid as a series combination of circular coils? Do you have any objection? Several circular coils, if you align in a line, it will constitute solenoid only. Now instead of taking long solenoid, I am taking only one turn. One circular turn I am taking. This is one circular turn of radius capital R. Two people have to find coefficient of self-inductance of this single turn circular coil. Quickly. So only one circular coil. I should not come, madam. Okay. What we can write? Coefficient of self-inductance equal to total flux by current. Total flux means only I have given single turn only enough. You don't need to multiply capital N. Only one turn is enough. What is the magnetic flux passing through this coil? L equal to how much? Magnetic flux passing through the center. This actually I have drawn very large, but actually it is very small. Center is almost all equal to its circumference. So, what a magnetic field due to this current, let's say I ampere at the center. Flux equal to how much? B into area of the coil by I. What a magnetic field at the center due to circular current carrying coil? How much? U naught I by R into area by I. I cancels out. U naught. Sorry, 2 I forgot. 2 compulsory should come. And what is area of the circular cross section? Pi R square by 2 into R. R cancels out. So mu naught pi into R by 2. This is the coefficient of self-inductance for the circular coil. Definitely will ask me one more question. The views are one more task we will do. Correct? Shall I give a? Okay. Same thing, but n number of turns. Same small circular coil, but this time how many turns have taken? N number of turns have taken. Find its coefficient of self-inductance. Very good. That's all. Very good. Only here n time.
Not audible, sir.
Now definitely you will ask me one more question, sir. Please give sir like that you will correct. If you want to do, see here, one square coil I am taking. Which coil? What is this? One very small, very small square coil I am taking. Of length of each side is how many meter? Let's say L meter. Now you have to find the coefficient of self-inductance. The time starts. Two root two U naught L by 5. Any supporters for this answer? So here every square has how many sides? 4 sides. As I told you, it is very tiny coil. So every wire is acting like a finite straight wire. Let's say the current is I ampere. This first finite wire is subtending how much angle? Here 45 and here also how much? 45. This current carrying wire number 1 producing magnetic field into the string. Why? Because keep your thumb in the direction of the current, bring the fingers at center, going into only. Correct? So I can write coefficient of self-inductance equal to how much? Total flux passing through square loop divided by current I ampere. What? Magnetic field and into area of cross section divided by current. How many segments are producing magnetic field? 4 segments are producing magnetic field into the screen. So I can write 4 into magnetic field into single finite wire. 4 into what a magnetic field into each finite wire formula? Mu naught by 4 pi into I divided by perpendicular distance. What is perpendicular distance? L by 2. L by 2 into how much? Sine of 45 plus sine of 45. This is a magnetic field. And what is the area of cross section? L square and whole divided by I. I ampere. 2 ones are 2 twos are and 2 ones are 2 twos are. Simplify coefficient of self-inductance how much? Mu naught by pi and into how much? I by L into here 1 by root 2 plus 1 by root 2 how much? 2 by root 2 means root 2 and into L square. LL cancels out. So I already cancelled mu naught root 2 L by pi is your answer. Okay. Thank you. Right? Here also 2 root. You said same, huh? Very good. If n number of turns are there, what you have to do? 2n. Very good. You have to multiply with n. I think definitely your confidence levels shooted to sky rocket high. Definitely will demand one more question. You want No, I will give you. So take one triangular loop of length how much? L meter and L meter. Is also very small. Find the coefficient of self-inductance. All sides are same means definitely that is equilateral triangle. Yeah. 452. Give me one material. Students, write homework problems. Page number 181. Students, these are theory questions. Please go through everything. No need of solving. Only 10 questions are there, student. Exercise number 1. Low, 2 minutes. Please write down page number 181. Exercise number 1. All problems. Those are not problems. Statement type questions only. Then everyone, page number 199. Now here problem started. Page number 199. Question number 20, 19, 17. Page number 201. Page number 201. Question number 34. Page number 202. Question number 36. 37. Okay. Mostly here conceptual questions only there. Only problems 6, I think. Finish this problem. How much? How much? Tell me once again. 9 root 3 u naught L by 8 into 5. Any supporters for this answer? Another? Not understood. No problem. 3 by 4 u naught L by. So two different answers are there. So this is one equilateral triangle. Assume some current I ampere is flowing at the center. If this L length of the each side is L, assume. What is the perpendicular distance? Total angle is 60, means this angle is how much? 30 degree. I will assume perpendicular distance x. This is how much? L by 2. I can write sin 30 equal to how much here? Opposite side by, sorry, tan 30 equal to opposite side by adjacent side. Na? So I can write tan of 30 equal to how much? Opposite side by adjacent side L by 2. Tan 30 means what? Well, 1 by root 3 equal to 2 into x by L. So x equal to how much? L by 2 root 3. Every side is acting like a finite wire. So I can write here coefficient of self-inductance how much? I can write coefficient of self-inductance equal to how much? 3 into total magnetic flux. Sorry, total magnetic flux divided by current. What is magnetic flux equal to? B into A and divided by I. Magnetic field due to 3 finite wires. Every side is acting like a finite wire. So I can write 3 into magnetic field due to each finite wire. What is magnetic field due to each finite wire? Very good. Mu naught by 4 pi into I by perpendicular distance x equal to how much here? L by 2 root 3 and into this one value how much? Sin 60 plus sin 60 na? Yes or no? Sin 60 means root 3 by 2 plus root 3 by 2 how much? 2 into root 3 by 2 and into area of the triangle how much? Half into base into height. What is the base? Very good. Root 3 by root 3 into L square by 4. If you remember this formula directly you can do, or else if you don't remember also half base into height you can do, and whole divided by I ampere. I cancels out. This 1L cancels out. 2 cancels out. Root 3 into root 3 how much? 3. 3 3s are how much? 9. 2 1s are 2 2s are. So 2 will come. So how much? What is our answer? 9 root 3 by 8 into 5. How much? U naught. L by 5 is your answer. I already said. This gang is perfect. Okay. Right. Okay. So like a good children, work hard. I explained your situation status in the form of estimated average. Understood? Come to reality. Work seriously. Minimum 8 to 10 hours. Work hard. And target 700 plus. At least you will get 650 like that. Attempt every question. Okay. Thank you, student. Now you can leave. We'll meet tomorrow. Bye.